clockwise and section right clockwise creates the hogging nature, and this is treated as negative as per our sign convention. This is of minus 15x square. Minus sign means the diagram which comes below the baseline. X is equal to 0. If we take x is equal to 0, this value is 0. Then x is equal to 1 means the variation we achieve over here. Then minus 15 into 1 square, that is 1. 15 into 1, 15. This ordinate is of 15. Now this is an equation of parabola. This equation of parabola. So should I join this parabola like this, or should I join the parabola like this? For that, let us we take an intermediate point that is of 0.5 meter. If we take the 0.5 meter, BM at 0.5, that is of minus 15 into 0.5 into 0.5, and this comes to be minus 15 by 4. This ordinate is of this value, because if I will take a straight line relationship, then this central ordinate is of 7.5, half of that. But this value, which is once again less than that of 7.5, means our actual diagrams comes like this, parabola like this. Next, the value of bending moment at C. Between D and C there is no load, so the variation is given by inclined straight line. Inclined straight line, no load is there. What is the ordinate? What is the ordinate? Then the bending moment, let us we take over here on the next page so that we will visualize better way. Bending moment at C is equal to, at this section over here, is equal to minus 30 into 1 into the distance is half into, not into, plus 0.5. Means this load is acting over here. This load is acting over here. 30 into 1 total load acting at the CG. So 0.5 plus 1/2 is the total distance. The same equation we achieve over here. So minus 30 into 1, that is of minus 30. So we achieve this ordinate is of 30 joined by inclined straight line. Next over here at this section, the answers definitely of magnitude of 55. It must be there. You can check it out by taking the same approach over here. Bending moment at A is equal to 30 means minus sign into 1 into 0.5 plus 0.5 plus half, 0.5 plus 0.5 plus half, minus 20 into 0.5. This gives to be minus 55 and joined by inclined straight line, minus sign. So just visualize, this is of inclined straight line with different slope, this is of inclined straight line with different slope, and this is of parabolic nature. So depending upon the type of the load, the bending moment variation and its behavior changes. So this is our bending moment diagram. Visualized the same value over here on this PPT. This is of parabolic nature, then this is of inclined straight line, and this is once again inclined straight line but of different slope. So I wish now it is very much clear to you how to plot the shear force and the bending moment diagram for a cantilever beam, specifically when it is subjected to the UDL and the point load. Now, next problem. Here in this particular problem, a next type of load, that is of uniformly distributed load, we are taking over here. Beam, that is of cantilever beam, a length of 2 meter, subjected to the UBL, specifically a triangular load 0 at the tip and 20 kilonewton per meter at the support which is acting on the beam. UBL load is acting, and our intention is to plot the shear force and the bending moment diagram. Means our intention is to find out the variation of shear force along the length of the beam and variation of bending moment along the length of the beam. As usual, the first step, even though it is not necessary, let us be found out the reactions, support reactions. So there are 3 support reactions over here. Sigma H means we found out RAH. For sigma V we found out RAV, and third, by using sigma M we found out MA value over here. So now first one, that is sigma H is equal to 0 and not a single external force is acting on the system, means RAH is equal to 0. Sigma V is equal to 0, then in that case the RAV that we are assuming as is upward. So RAV, which is of plus sign as per our sign convention for reaction, minus, that is the triangular load which is acting downward, that is the area of triangle, half into 20 into 2, and we achieve RAV as is 20 kilonewton. Plus sign indicated that our assumed direction of RAV upward is right. Next, sigma MA is equal to 0. This sigma MA means summation of all the moment of the forces acting over here is treated as 0. Assuming the sign convention of moment at A, which is of anti-clockwise nature, so minus MA plus the load, the triangular load is the area of triangle, half into 20 into 2, into the load which is acting at the CG. CG is 1/3 from here, 1/3 of base, 1/3 of 2. So 1/3 of 2 is equated with 0, and simplifying this equation we got MA is equal to 13.33 kilonewton into meter. This positive sign indicated that our assumed direction of MA, that is of anti-clockwise nature, is right. Next, our intention is the plotting of shear force and bending moment diagram. Let us take over here the tabletop. The given beam, cantilever, subjected to UVL, specifically triangular load, (20 kilonewton per meter). Now, our intention, we know the reactions also. This is of 20, this is of 13.33. Now, our intention is to plot or to find out the variation of shear force along the length of the beam. For that, let us take a section over here. Distance x from B. Why we are taking a section? Because we want to visualize which kind of the diagram, which kind nature of the diagram will be possible for shear force. So now my figure is look like this. Section XX, distance x is there. Now intention is to find out this ordinate. What is this ordinate? So for 2 meter length, if the vertical ordinate is 20, for x it is how much? So for 2 meter length, if the vertical ordinate is of 20, for x it is how much? So 20x by 2, and that is nothing but 10x. So this ordinate is of 10x. Now shear force at xx is equal to area of triangle unbalanced vertical load from any of the section. Right now we are taking a section from the right side. So unbalanced vertical load is half x into 10x, and that is of 5x square. See, the shear force, we got an equation 5x square. X square, it is an parabolic nature. So if we take x is equal to 0, we got shear force at B is 0, and if we take x is equal to 1, that is at the center, we found out shear force at center is 5 into 1 square, 5 into 1, that is 5, and if we take x is equal to 2, shear force is of 2 square, 4, 4 into 5, 20. So if put the ordinate over here, the 20 ordinate is over here. Join these 3 lines with the help of parabola, and we achieve the diagram like this. Sign convention, yes, definitely positive. Why positive? Section right downward, as per this sign convention. Section right side downward. So what happens on left side? Definitely upward. This is treated as positive as per our sign convention. So this is the basic shear force diagram that we achieve with the help of this U, V, N. So see on this PPT. Parabolic nature of variation of shear force diagram. 0 at the tip, 5 at the center, 20 at the support. That is the reaction itself. So now I wish you will understood how to plot the shear force diagram when it is subjected to the uniformly varying load. Let us switch to the next, that is the bending moment diagram. Come to this tabletop. The figure is over here. Bending moment diagram. What is bending moment diagram? Bending moment diagram is defined as, or bending moment specifically is defined as, algebraic sum of the moment. Important word is algebraic sum of the moment of the forces to the left or right of the section. Here in our case, right of the section. So now to find out or to know precisely the word, to know the variation of bending moment along the length of the beam, let us take a section XX, distance x from B, and this is the free body diagram, or we can say the right sectional part for this particular beam. We know this vertical ordinate as we understood in case of the shear force diagram. This is 10x, this distance is x. Now switch over here, tabletop. What is bending moment at xx is equal to unbalanced or algebraic sum of the moment of the forces to the right side. So here the only single force is acting, that is the triangular load, that is of half into x into 10x. What is this? This is load multiply by perpendicular distance. Now this CG is over here. This distance is of 1/3 x. So multiply by 1/3 x, and we achieve 1/6 into 10x cube, that is of 5/3 x cube. This is the equation of bending moment, or this is the value of bending moment. So this is 5. Clearly it is 5/3. 5/3 x cube. Now this is the magnitude of bending moment at section xx. Question is about nature. Nature means whether it is plus sign or whether it is minus sign. So now when the load is acting over here, see, this creates a clockwise moment. Precisely section right side clockwise creates hogging nature. What? Hogging, treated as negative as per our sign convention. So all the cases is negative. Minus 5/3 x cube. This is of cubic parabolic nature. Repeat the word, cubic parabolic nature. If we put x is equal to 0, bending moment at B is equal to 0. And if we take x is equal to 1, we achieve bending moment at center is minus 5/3. And if we take x is equal to 2, that is at support side, we achieve bending moment is of 2 cube. 8 into 5, 40. 40/3 minus 13.33. Now let us put this value over here in this diagram. Clearly visualize, this is 0. This magnitude is of 13.33. This magnitude is of 5/3. And the value of 5/3 is of 1.67. Joining all this with the cubic parallel.